Man, I love this song.
Man, I love this game.
Hey Riley, we should probably do our chemistry homework.
Nick, I'm in the middle of something.
But Riley, we really need to do our chemistry homework.
Nick, this is very important.
But Riley...
This is my future.
But Riley...
You made me die.
But we really need to do our chemistry homework.
Fine, you already ruined my day anyway. We all know that anything and everything is made up of atoms, and each atom has its own subatomic particles, neutrons, electrons, and protons.
Even though atoms are small, they all have their own mass, which is known as the atomic mass, which is measured in atomic mass units.
Subatomic particles have their own masses. Protons and neutrons have one atomic mass unit, or AMU, and electrons have 5 times 10 to the negative 4th AMU. Their mass is so small and irrelevant that we don't really use that in calculating the atomic mass of an atom of an element. You know, Nick, this video is kind of boring so far.
You're right. No, we need more explosions! An atom is most stable when the number of protons and the number of electrons are equal. Since protons are positively charged and the electrons are negatively charged, this gives the atom no charge, which is how they're naturally found.
An atom can only lose or gain electrons. When this happens, the atom becomes an ion. An ion is just a charged atom.
But how do they lose or gain electrons?
Each atom has a certain number of valence electrons. Valence electrons are the amount of electrons in the outer shell of an atom. All atoms want a full outer shell, which means some atoms must lose or gain electrons to complete this full outer shell. For example, cesium has 1 valence electron. This means it must lose 1 or gain 7 valence electrons. Now, it makes more sense just to lose 1 because it's just a lot easier. Now, cesium will live happily ever after with a full outer shell. Got it, Nick?
What? Sorry, I wasn't listening.
Alright, so rehearsals from Tuesday, Thursday, 6 to 8 every night. Just make sure you bring your camera and props.
Here I am, here. What? What's this?
Oh, hey, did you get my text?
No, I didn't get your text. What's going on?
Well, you see, you've been late to the last 3 rehearsals, and your acting performance has really not been up to par recently.
I can't believe you tried to replace me.
I know, I'm sorry. I just really take these things seriously.
What are you trying to say? I mean, I've been studying chemistry 24/7 for the past month. What part of the video are you on now?
Let's see. It looks like we're going to be talking about some acids and bases.
Oh, I know all about that. I was just studying that yesterday. There are 3 ways to categorize compounds: acids, bases, and neutrals. To determine whether a compound is an acid, base, or a neutral, we can use the pH scale, which is basically like a number scale from 0 to 14. Basically, acids will fall from anywhere from 0 to 6.9, neutrals will be at 7, and bases will fall from 7.1 to 14 on the pH scale.
But Nick, what other ways can you tell whether a compound is an acid, base, or neutral?
Well, weirdo, acids normally have a sour taste and corrode metals, bases normally have a bitter taste and are pretty slippery, and, well, neutrals normally have properties that are similar to that of water.